Linear functions. We'll begin with the standard form of the equation of the line. Ax plus by equals c. A and b are real numbers. A can't be 0 and b can't be 0. An example is 4x plus 3y equals 12. I can solve this for y. So I have 3y equals minus 4x plus 12. Now divide both sides by 3. So y equals minus 4/3 x plus 4. And we can see the line here. 4x plus 3y equals 12. And of course, that is the same line if we solve it for y. Y equals minus 4/3 x plus 4. If we want to graph this equation, it's a good idea to find the x and the y intercepts. Remember, when x equals 0, that gives us the y-intercept. So when x is 0, y is 4. So of course that'll be the point 0, 4. And then we'll find the x-intercept. So that will be when y equals 0. When y equals 0, that will be the point 3. So this is 3, 0. So technically, in order to graph a line, you really only need 2 points. But it's always a good idea to do a checkpoint, just as a sanity check. So let's try -3, y is 8. When x is 0, y is 4. When x is 3, y is 0. And our checkpoint, when x is -3, y is 8. And that enables us to graph our line. In this example, b does equal 0, so we just have 1 times x equals 1. That means x is always 1. The x value is always 1. But the y value could be anything. So we could do y equals -4. So that would be the point 1, -4. We could do y equals 0. So that would be the point x is 1, y is 0. Or we could do +4. That would be the point 1, +4. And then we can use those points to graph the line. But whenever x equals a constant number, we're going to have a vertical line. So we can graph the point 1, -4, point 1, 0, the point 1, 4, and connect them, and we see we have a vertical line. Next we have the equation of a horizontal line. Y equals 4. This is where the a value is 0. You just can't have both a and b 0. One could be 0. Either a could be 0 or b could be 0. So in this case, this is a horizontal line. Y is always the value 4. So x could be anything. So let's try -4, 0, and +4. So that will give us the points -4, 4, and the point 0, 4, and the point 4, 4. But it will be a horizontal line through the value y equals 4. And again, if we plot our 3 points, -4, 4, 0, 4, 4, 4, and connect them with our line, we see we have the horizontal line through the point y equals 4. An important feature of any line is its slope. The slope of the line passing through the points x1, y1 and x2, y2 is designated by the letter m. And it's the change in y, that little triangle means delta y, or the change in y over the change in x. And this is y2 minus y1 in the numerator over x2 minus x1 in the denominator. And of course we cannot divide by 0, so x2 minus x1 cannot equal 0. Let's consider example A. We want to find the slope of the line that connects the points -3, -1, and 1/2, 2. So this I'll call x1, and this one is y1, and this one I'll call x2, and this one is y2. Now, when I write this red above, that's really what I'm thinking. That should be a mental step. I don't really need to write that down, and it is not correct notation to do that. So the slope then is m equals y2, which is 2, subtract y1, which is -1, all over x2, which is 1/2, subtract -3. So m equals 3 divided by 7/2. So I can actually put this into my calculator. It's 3 divided by 7/2. And then I can say math, frac, output as a fraction, and that gives me 6/7. So m is 6/7. Now let's find the slope from the point 0, 3 and the line that connects this point to the point -2, 3. So I'm going to use my formula. M equals y2 in this case is 3, subtract y1, which is 3, all over x2, -2, subtract 0. So that actually means that m equals 0 divided by -2, and that's just m equals 0. Whenever I have a 0 slope, that's actually the slope of a horizontal line. In this case, because the line goes through y equals 3, has a slope of 0, it never goes up or down, it goes horizontally through the point y equals 3. Finally, I want to find the slope of the line that connects the point 3, 2 to the point 3, -2. So m equals y2 is -2, subtract y1, which is 2, all over x2, which is 3, subtract x1, which is 3. So that tells me m is equal to -4 divided by 0. But we cannot divide by 0. This is undefined. So this slope is undefined. And it is always true that a vertical line, x equals 3 is the vertical line in this case because x equals 3, has an undefined slope. Next we have the slope-intercept form of the equation of the line, or y equals mx plus b, or we could write it in its functional notation form, f of x equals mx plus b, where m is the slope and the point 0b is the y-intercept. In this example, I'm given the slope of 5 and the point 2, -2, and asked to write an equation of the line that passes through that point. I have a bit of a problem because that is not the y-intercept, but I do know that y equals 5x plus b because the slope is 5. So I know that this m equals 5. But I also know when I'm given the point 2 and -2, I know that when x equals 2, y equals -2, so I can substitute that. Y equals -2, that equals 5 times 2 plus b, and I can actually find b in this way. So I have -2 equals 10 plus b. b then would equal -12. So my equation of my line is y equals 5x minus 12. We have another equation of the line, the point-slope form, given by y minus y1 equals m times the quantity x minus x1, where x1, y1 is a point on the line and m is the slope of the line. In the previous example, write an equation of the line that passes through the point 2, -2 and has a slope of 5. We could also use the point-slope form. We could say y minus y1, so that's minus -2, equals the slope m times x minus x1, which is just 2 in this case. So I have y plus 2 equals 5x subtract 10. I'm going to have to subtract 2 from both sides. Y equals 5x minus 12. Parallel and perpendicular lines. M sub 1 and M sub 2 are the slopes of two lines. Parallel lines have the same slope. So m sub 1 equals m sub 2. Product of the slope of two perpendicular lines is -1, which means m sub 1 multiplied by m sub 2 equals -1, or m sub 1 equals -1 divided by m sub 2. Or we could have a vertical line x equals b and a horizontal line y equals a. Of course, a horizontal and a vertical line are perpendicular. In the example, we're asked to write the equation of a line parallel to the line y equals 4x plus 1 that goes through the point 1, 7. I think it would be a good idea to use the point-slope form. So we know the slope is m equals 4 of both lines because in the case of parallel lines, the slope of the first must be equal to the slope of the second. So here's our point. So we know y minus y1, which is 7, equals m times x minus x1, which is 1. So y minus 7 equals 4 times x minus 1. Y minus 7 equals 4x minus 4. Y equals 4x plus 3. So we have the graph of y equals 4x plus 1 and the graph of y equals 4x plus 3. You can see they're parallel. Now we're asked to write the equation of a line perpendicular to y equals 4x plus 1 that goes through the point 2, 1/2. So we know that the slope that we've been given here is 4. So for a perpendicular slope, we would have 4 times m2 must equal -1. So our second slope that is perpendicular is minus 1/4. Y minus y1 equals m times x minus x1. And in this case, I'll have y minus 1/2 equals at -1/4 x minus 2. So y minus 1/2 is equal to minus 1/4 x plus 1/2. Y equals minus 1/4 x plus 1. And we see here's our line, y equals 4x plus 1. And here's the line, y equals -4x plus 1. And they are indeed at right angles or perpendicular. So in summary, we have 3 different forms of the equation of a line. The standard form, ax plus by equals c. The slope-intercept form, y equals mx plus b. Or the point-slope form, y minus y1 equals m times the quantity x minus x1. We also learned the slope of the line is the rise over the run, or the change in y over the change in x. Parallel lines have the same slope, and perpendicular lines have a product of the slopes that equals -1.